Hi y'all, it's Coach Fred here, and today I'm going to be talking about an SAT and ACT strategy called the vertical scan. This can be used on the writing sections of these tests as well as the math section, and on ACT even the science section. It's a really helpful way to read answers to questions to help you eliminate and to narrow down what you're looking for. So here's an example of the vertical scan, okay? All right, so in planning maintenance for cities' infrastructure, a civil engineer estimates that starting from the present, the population of the city will decrease, I always underline words like that, by 10% over 20 years. If the present population of the city is 50,000, which of the following expressions represents the engineer's estimate of the population of the city T years from now? Okay. So I first look at the answers, and if instead of looking horizontally, I'm going to look vertically. So I can see that all of them have a 50,000. Then I can see that two of them have 0.1, two of them have 0.9. And then in the exponent for both of them, I have 20t and t over 20 and 20t and t over 20. So I'm going to work from left to right, but vertically down, I'm helping myself by seeing what I'm looking for. All right, so the content on this is that it's an exponential function in the form y equals a sub 0, 1 plus or minus r to the t. And this is on an annual basis. If it decreased 10% every year, then it would be t. Okay, so it's decreasing, so that would be 1 minus the percent. So a sub 0 is the original amount, so 50,000, that's where that's coming from. Then 1 minus 0.10. So that's where I get the 0.9, okay? So that allows me, at this point, to stop and get rid of A and get rid of B. All right, now, like I just said, if this was every year, then it would just be T. But because this is happening every 20 years, that means that in 1 year, 1/20th of it will have decreased. So this would be T over 20. And so my answer is D. Now, this video isn't about the answer as much as how we're reading the answers in a vertical motion, again, called the vertical scan. One part at a time. Okay, so like here, I've got this table. Now this table is presented to me horizontally. It tells me the table above shows values of the linear functions. If you've watched any of my videos, you're really looking for linear. When it's linear, you're either looking for a slope or rate of change or a y-intercept or even possibly an x-intercept. Okay, so which of the following defines f? So I vertically scan. They're just giving me function notation, and then I notice that I have n, 2n, 3n, and 4n. So if they're in the form f of x equals mx plus b, they each have a different slope. I also notice that if I look vertically, the y-intercepts are all different. So I can either calculate the slope or calculate the y-intercept. All right, so I'm going to work with the slope, and I'll show you both ways. If I work with the slope, my change in y appears to be going up 3 every time. And it seems to be going up 1 along the x. So remember, it's change in y over change in x. So my slope is 3 over 1. So I know that C would be my answer. All right, but if you chose to use the y-intercept in the table, well, that means the y-intercept is where x, or in this case n, is equal to 0. So if I work my way back 1, I would be at 0. So I'd need to work my way back 3. So that would put me at -5. So either method would have gotten you to C, but again, vertically scanning helps me determine I just need to compare one thing. All right, let's try one more, or two more. Here we've got this polynomial, and it says, which of the following is the sum of the two polynomials? And in looking at this, I notice that I've got 8x squared twice and 8x to the fourth. I've got -7x and a +7x, a -7x squared and a +7x squared, and then -4 straight down. So it really doesn't matter, my last term. If I add these together, I'm going to get -4 in the last spot. I guess the big question is they're testing us here on what we know about adding exponents. And let's just remember that adding exponents is like combining like terms. We don't change the exponent when we add them. So this would just be 8x squared minus 7x minus 4. So you can see I would have gotten rid of both 4's. I also knew that when I added -5x and -2x, I'd get -7x. So that would have helped me narrow it down to A. All right, the last one, and I find it really helpful to use the vertical scan here, is with inequalities. Jackie has 2 summer jobs. She works as a tutor, which pays $12 per hour, and she works as a lifeguard, which pays $9.50. She can work no more than 20 hours per week. So when I have inequalities and I see the words no more or at least, I'm going to be paying attention. All right, she works no more than 20 hours per week. So I scan, but she wants to earn at least 220. Which of the following systems of inequalities represents the situation in terms of X and Y? X is number of hours she tutors, Y is the number of hours she works. So I look first at the first inequality given. So I've got 12x plus 9.5y, and if I scan vertically down, I see that all of them are the same with the exception of the inequality symbol. So, and that's dealing with the 220. She wants to earn at least 220 per week. At least means greater than or equal. So she wants to make at least 220. So she wants to be, she wants this amount to be greater than or equal to 220. So that means I'm going to get rid of B and I'm going to get rid of A because we don't want it to be less than 220. We want it to be greater than 220. All right, so that helped me get rid of 2. Now I look down at the X plus Y's. The only difference vertically is their symbol. So X and Y is hours, and she wants to work no more than 20 hours. That means less than or equal to, which would then give me C. All right, guys, so that's what I mean by the vertical scan. Look at the answers vertically to see what they have in common and try and eliminate the pieces that you have based on the question. All right, hopefully that was helpful. And again, I said it could be used on the writing and or the science on the ACT and SATs. So pay attention and look for the vertical scan. Have a great day.